Hello and welcome to our new section 9.2 on special right triangles. This lesson is going to be split up into two parts. And we're going to first talk about our first special right triangle, 45, 45, 90. So before we even start this, I actually want you to try these three. This is going to be a little bit of a discovery. This is in pink. You don't have to copy this down, but it'd be good to do this on a scratch sheet of paper. Now, I want you to kind of try these three problems out. Solve for x, y, and z, given that these legs are actually all congruent. If these legs are congruent, that actually means that this is a 45, 45, 90 degree triangle, because if sides are congruent, then angles are congruent, opposite angles, or base angles are congruent in an isosceles triangle. And since this is already 90 degrees here, that leaves only 45, 45. So in all of these cases, we'll have 45, 45, 90. And I want you to realize something, what x, y, and z, there's a shortcut to this. So if you want to pause the video really quick, solve them, and then see if it matches up with what I have. So if we do this the long way, 2 squared plus 2 squared is equal to x squared. 2 squared is 4, so 4 plus 4 is equal to 8. We have 8 is equal to x squared. And then once you square root both sides, x should be equal to 2 root 2. Okay? Doing the same thing for the next one. 3 squared is 9, so we could do 3 squared plus 3 squared, and we could repeat this process over and over. Y squared, we'll get 9 plus 9, which is equal to 18. It's equal to y squared. You square root both sides, and then you end up getting y is equal to 3 root 2. Right? And last but not least, 4 and 4. So 4 squared, I'm going to skip a step here. 4 squared and plus 4 squared is 16 plus 16, which is equal to 32, is equal to z squared. Square root both sides. And you break this apart, you get square root of 16, which is 4. So you get 4 root 2 again, and you get z is equal to that. So hopefully you realize this is that the hypotenuse is actually equal to, if you notice, the hypotenuse and the leg, let's actually make this color stand out a little bit more. Let's do blue. The hypotenuse is always the leg multiplied with root 2. So for instance, the leg in the second one is 3. So we take the 3 and multiply it with root 2. Take the 4, put that in as part of the leg, multiply that with root 2. That is always the pattern of 45, 45, 90 degree triangles. Okay? And that's what ultimately I want you to hopefully realize and recognize. It's kind of like Pythagorean triples. If you recognize a Pythagorean triple, the problem becomes significantly easier to do. If you recognize it's a 45, 45, 90 degree triangle, this problem becomes a lot easier to do. You can jump straight to the conclusion that if this is a 45, 45, 90, then we could say, oh, the hypotenuse will be equal to 2 times root 2 because this is the leg. Now, whenever we write 45, 45, 90, I like to do it in this little format, 45-45-90. And underneath it, I'm going to write 2 different versions of this. We could call this leg root 2. This is exactly what I was saying. No matter what the leg length is, it's going to be, for instance, if this was 2, the sides of the triangle would be 2, 2, and 2 root 2. Those would be the legs. That would be all the pieces to the right triangle. Okay? So you could write it out like that. That's perfectly fine. You could also write this as if the leg was A, and I'm going to use A for this. It doesn't matter what letter you use. If the leg is A, it would be A root 2. So any number you put in for A is just a variable. If I, for instance, put in a 10, or let's say 9, it'd be leg is 9, hypotenuse is 9 times root 2. Okay? And this is always the pattern that you see for 45, 45, 90 for the sides of the triangle. Okay? The hypotenuse is always that last part. It is leg times root 2. So looking at this, we should be able to kind of piece this together. You could always do it the long way if you really, really want to. You could use the Pythagorean theorem every single time. But you should hopefully realize, and this is missing a right angle. That's bad of me. You should realize, okay, we have 90 degrees here, 45 here. This last piece is 45, so this is 45, 45, 90. Legs in an isosceles right triangle are congruent. So we could say x is equal to 7 right off of the bat. And then the hypotenuse is always equal to leg squared. So we know that a is 7. So if you really want to, you could do that like 7, 7, 7 root 2. Okay? And you're following this pattern, leg, 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 root 2. So you could jump to that conclusion. Y is equal to 7 root 2. If you don't believe me, do the math for it, and you should arrive at that same conclusion. Now, it does get more challenging, because what happens if you have the hypotenuse instead of the leg? Okay? Well, this one's actually kind of conveniently written, because if we know that this is a 45, 45, 90, and hopefully you do because we have 90 degrees here, these two angles are congruent. So since these two angles are complementary to each other and they're equal to each other, we take 90 degrees divided by 2 and you get 45, 45. Okay? So once you have that and you know it's a 45, 45, 90, you could say that this length is x as well. And if you want to do the Pythagorean theorem, you absolutely could. But if you remember this pattern, a root 2, you could fill in this information, or if you would say leg, leg, leg root 2, you could say x, because we don't know what this is, but we have two x's here, and this would be 5 root 2. But since a is just this component, it's not the full root 2, then we could say x is actually equal to 5. Okay? If you don't believe me, let's do it. X squared plus x squared for the legs is equal to 5 root 2 quantity squared. X squared plus x squared is 2x squared, because you add them. 5 root 2 squared is 5 times 5 times 2, which is 50. Divide both sides by 2. X squared is equal to 25. Square root both sides, and as we see, x is equal to 5. So it's very, very convenient if your hypotenuse is written as a radical 2. If it's not written as a radical 2, then you have some work to do. So in this particular case, once again, I actually should have angle tick markers here. That's bad of me. This is a 45, 45, 90 now with the angle tick markers, and we have a hypotenuse that is not a root 2. Okay? We do know that these legs are in fact congruent, so I'm going to put x and x here. I'm going to put tick markers here just to further illustrate that. And we could always do this the long way. X squared. Or we could even call these a's if we want to. Let's do a because we were using that letter. So let's do this as a. And technically this would be a root 2. Now, two ways you could do this. You could use the Pythagorean theorem. A squared plus a squared is equal to 10 squared. And then you could solve. You could say 100 is equal to 2a squared. Divide by 2. A squared is then equal to 50. Square root both sides. 25 goes into it, which square root of 25 is 5. 25 times 2, so that's root 2. And this is your a value, your side. Okay? Now, the other way to do this is since these are equal to each other, solving using that equation. So I'm going to say a root 2 is equal to 10. Well, we need to get a by itself, so we actually need to get rid of the root 2. And since this is multiplication, we are going to be dividing by root 2. Root 2's cancel. You get a is equal to 10 over root 2. But hopefully you remember, you can't just have radicals in your denominator. So we need to fix this. The way you fix this is you need to multiply the numerator and the denominator by that radical in the denominator. So 10 times root 2 is equal to 10 root 2. Root 2 times root 2 is just 2. And then we have to simplify one more time. 10 divided by 2 is equal to 5 root 2. And you see we get the exact same answer. Now the absolute shortcut to this is to take if you have a 45, 45, 90, there is a third even shorter version to this. Pythagorean theorem is a long version. Doing some algebra is a little bit of a shorter version. The shortest version of this, and let's do this in purple, is to take your hypotenuse. Your hypotenuse is equal to 10. Okay, if it's 45, 45, 90, you could take your hypotenuse. You could then multiply this by root 2 over 2. Okay? Because that's exactly what we just did. And in this particular case, it will work because 10 times root 2 divided by 2. Here's probably a better way to write this. Take your hypotenuse, divide it by 2, which is equal to 5, and then tack on the root 2 at the end. Okay? Now that's an absolute shortcut. I don't recommend it unless you completely understand these two concepts, but it is a very, very convenient shortcut if you are able to recognize it. Okay? So tack on that root 2 divided by 2, and then you could actually get your answer even shorter. All right. If you do have any questions on 45, 45, 90, please let me know. Other than that, I'll see you in the next one. Bye.